Hi everyone, welcome to the class. In this class, we learn how to convert terminating decimals into p by q form and general form of denominators of p by q when p by q is a terminating decimal. What is p by q? P by q form nothing but rational numbers. So the numbers which can be written in the form of p by q are called rational numbers, where p comma q are integers. Integers means the numbers may be positive or negative numbers or 0, but q not equal to 0. You can take any p comma q numbers from integers, but except q should not equal to 0. For example, 1 by 2, 1 by 3, 5 by 6, all these numbers are called rational numbers. They can be written in the form of p by q. So we can represent rational numbers in decimal forms. This is called decimal expansion of rational numbers. Decimal expansion of rational numbers. That means representation of rational numbers in decimal form. This is called decimal expansion. So decimal expansion, rational numbers, decimal expansion of rational numbers means representation of rational numbers in the decimal form. So how to represent one by one after one? Decimal expansion of rational numbers are two types. Decimal expansion of rational numbers are two types. First one, terminating decimals. Example 1.25, 0.475, 2.04. These are terminating decimals. This number terminates after 2 digits. This decimal fraction terminates after 3 digits. This decimal fraction terminates after 2 digits. Number 2, non-terminating decimals. Example 0.333. This is non-terminating but recurring. Non-terminating but recurring decimals. 0.333, 3 recurring. So this can be written as 0.3 bar. Otherwise, 0.83 bar. That means 0.83333. 0.8333. Like this, 0.45 bar. That is 0.454545. 4, 5, and so on. These decimals are also can be written as P by Q form, and these decimals also can be written P by Q form. In this way, rational numbers are two types here. Those are terminating decimals and non-terminating but repeating or recurring decimals. So now let us learn how to convert terminating decimals into P by Q form. For example, I will take here 0.475. How to convert this one into P by Q form? Just write this is called integral part and this is called decimal part. Write the number without decimal as it is, without decimal write the number, and divide the number by here 1000. Why? Because it terminates after 3 digits, 1 2 3, so write 3 zeros. Now I will write this one the P by decimal expansion. Prime factorization of 475. Let us write prime factorization of 475. 5 9 are 45. 5 5 are 25. Here 5 1 are 5. 5 9 are 45. So it can be written as 5 into 5 into 19. And this 1000 can be written as 10 cube, because after one there are 3 digits, 10 cube. So 5 into 5, 5 square into 19 by here 10 can be written as 5 into 2 whole cube. Now 5 square means 5 into 5 into 19 by 5 2 times, 5 3 times, and 2 3 times. 2 multiplied is 3 times. Let us cancel, reduce the fraction. 5 cancel, 5 1 5 cancel. Now write the remaining terms. 19 by 5 into 2 cube. So we can write the 0.475 as 19 by 5 into 2 cube, or 19 by 2 cube means 8, 8 5 is 40. 19 by 40. This is the P by Q form of 0.475, 19 by 40. Or decimal form of 19 by 40 is 0.475. So if we write the prime factorization of numerator and denominator, we get 19 by 5 into 2 power 3. Let us take one more example. 2.04. Here, how to convert 2.04 into decimal P by Q form? 204. Remove the decimal and count the how many numbers after decimal. How many it terminates after 2 digits. So write 2 zeros in the denominator. Don't count this integral part. Here integral part is 2 and decimal part is 04. So 2 digits are there in the integral part, decimal part. So write 2 zeros. Now you can reduce it into lowest terms by using 2 table. 204 by 1000. So 2 1 ja 202 by 50. Now 1 or 2, 2 5 ja 2 1 ja 2 2 ja 2 5 ja. 51 by 25. Now write the prime factorization of 51 by 25. 51 can be written as 17 into 3, 3 into 17, 5 into 5. So 3 into 17 by here 5 square. 5 square. This is the P by Q form of 2.04. Moreover, these two numbers are co-primes. We have to reduce the fraction up to we get co-primes. Co-primes means here only one is the factor of both numbers. Now let us take one more example, 0.8. Here 0.8, let us convert it into P by Q form. Write 8 without decimal, and there is one digit in the decimal part, so write 1 0 after 1. 1 0. If there are two digits, write 2 zeros after 1. If there are three digits, 3 zeros after 1. Now reduce it into lower terms. 2 4 ja, 2 5 ja. So this is 4 by 5. Now 7 by 10, 0.7. Let us take 0.7. To convert this one into P by Q form, we can write 7 by 10. That is equal to, because only 1 0, because after decimal there is only one digit. We get 7 by 10. Now 10 can be written as 2 into 5. And right, take one more example, 1.25. 1.25. This can be written as 125 by, after 1 we have to write 2 zeros because it terminates after 2 digits. Now reduce it into lower terms. 5 2 ja, 5 5 ja, 5 2 ja 0, 5 5 ja 25, 5 4 ja 20, 5 by 4. This is 5 by 4. Here it can be a 5 by 4 can be a 2 square. Now if we observe all these numbers, we can conclude one point. Let us write one more, one by one, one after one clearly. The 0.475 can be written as 19 by 2 power 3 into 5 power 1, and 2.04 can be written as 51 by 5 square, and 0.8 can be written as 4 by 5. 1.25 can be written as 5 by 2 power 2. 0.7 can be written as 7 by 2 into 5. Moreover, 0.3 also can be written as 3 by 2 into 5. If you observe all these pattern of all these numbers, here 2 power 3 into 5 power 1, here 5 square, here 5, here 2 power 2, here 2 power 1, 5 power 1, here 2 power 1, 5 power 1. What happens here? The denominator is other than 2 and 5. If we write another prime number other than 2 and 5, which type of decimal fractions we get? Let us check here. If I write here 1 by 3, if you divide 1 by 3, you get 0.333 and so on. We get a non-terminating recurring decimal. If I take these numbers, 0.5 by 6, if I take 5 by 2 into 3, other than 5, I will take another number 3, 5 by 6. Here we get 0.8333, non-terminating but repeating or recurring decimal, 0.83 bar. If I take 1 by 2 into 11, 1 by 22, this is equal to 0.045 bar. Bar means repeating. If I take 1 by 3 into 5, that is equal to 1 by 15, we get 0.06 bar. So observe here, the denominator, the prime numbers are here 2, 5, or only 5, here only 5, here only 2, if only 2 and 2 and 5, here 2 and 5. The denominator, if the powers are 2 power 3 or 4, 5 power 1, powers of 2, powers of 5, or powers of 2 and 5, then the rational number will terminate like this. The denominators are power of 2 like this, it terminating decimal. Power of 5 like this, it is also terminating like number. The power product of powers of 2 and powers of 5 also terminates. But here the denominator is 3 other than 2 and 5, non-terminating. Here are non-terminating recurring decimals. These are all called P by Q. That means rational numbers. Here terminating decimals. So here to see here 2 into 3 other than 5. 3 is here. Of course 2 is there, but other number, other prime number 3 is here. So that's why the number became non-terminating but recurring decimal 0.83 bar. Then here other than 2 and 5, 11 is here prime number, so it is also non-terminating. Here also 3 is here, even though there is 5, but 3 is here, so it is becomes a non-terminating recurring. So to terminate a decimal in the denominator, if you observe that the denominator is as power of 2 or power of 5 or power of 2 and 5, then only that fraction, that P by Q form, that rational number terminates. We can conclude that the decimal form of the terminating decimal is 0.475, and its P by Q form, denominator of the P by Q form is in the form of 2 power n and 5 power m. The form of denominator is the form of 2 power n and 5 power m. Here n is equal to what? Any non-negative integer n comma m or any non-negative integers n comma m or any non-negative integers. So n is equal to 3 here, m is equal to 1. Here 2 power n, 2 is not existed here, we can take 2 power 0 here, 1, and m is equal to 2. Here n is equal to 2 power n, n is not existed here, we can take n is equal to 0 here, 2 power 0, and that means 1 into 5 power m, 5 power m is equal to 1. Here n is equal to 2, m is equal to 0. Here n is equal to 1, m is equal to 1. Here n is equal to 1, m is equal to 1. So 0.475 can be written as 19 by 2 power 3 into 5 power 1. Here is the form of denominator is the form of 2 power n, 5 power m, and here n is equal to 3 and n is equal to 1. If you write the 2.04 terminating decimal into P by Q form, we get 51 by 5 square, and this can be written as, denominator can be written as 2 power 0 into 5 power 2. Some students may get a doubt, where is 2 here? 2 is not there, but we can write 2 power 0 and 5 square. So here n is equal to 0 and m is equal to 2. So this can be written as 51 by 2 power 0 into 5 square, that is equal to 51 by 2 power 0 means 1, 1 into 5 square you will get the same number 51 by 5 square. Moreover, 0.8 can be written as 4 by 5. Here denominator can be written as 2 power 0 into 5 power 1. Here n is equal to 0 and m is equal to 1. 7 by 10, that is 0.7, can be written as 7 by 2 into 5, 7 by 10. Here denominator, this is denominator. Denominator, in the denominator can be written as 2 power 1 into 5 power 1. So here n is equal to 1 and m also 1. So with this we can conclude that if x is a rational number, theorem number 1.3, if x is equal to p by q, a rational number, if its decimal form, decimal expansion terminates then q is in the form of denominator, q is in the form of 2 power n and to 5 power m, where n comma m are non-negative integers. If x is equal to p by q, take any rational number. If its decimal expansion terminates, it is a terminating decimal, then q means denominator. It can be written in the form of 2 power n, 5 power m, where n comma m are non-negative integers. Here is an assignment to you. Convert the following terminating decimals into p by q form and write denominator in the form of 2 power n into 5 power m. Question number 1, 0.84. Question number 2, 0.50. Question number 3, 0.75. Question number 4, 0.875. Okay.